All right, let's get right into it. Today, we're going to put on our detective hats. The case we've got is a classic, a computer that's just dead. It won't turn on, and it's our job to figure out what's going on. So let's start gathering those first clues.
So you hit that power button, and what happens? Absolutely nothing. Or maybe you see a little flicker of life, a fan spins for a split second, and then complete silence. Is this just a simple glitch, or is there something more serious hiding inside that case? Well, we're going to treat this like a real investigation, following every clue until we find the culprit.
And that's where our case begins, right at the scene of the crime. You've got a PC that tries to boot, the fans flash for a second, but then it just dies. This silent witness is our first big clue that, something's probably wrong with one of the core components.
Now, just like in any real investigation, the very first thing you do is secure the scene. When it comes to our PC, that means we need to get rid of any outside interference. We're going to get it back to a totally clean baseline state before we even start thinking about suspects.
So, what does clearing the scene actually mean for us? Well, it boils down to two really critical first steps. First, we're going to reset the CMOS. That's what stores all the motherboard's basic settings. And second, we need to drain every last bit of residual power from the system. You'd be surprised how many cases get solved right here, before you even have to crack open the case.
Okay, let's walk through exactly how to do this. Step 1, unplug every single cable from the PC. Everything. Next, you're going to look for that little circular coin-like CMOS battery on the motherboard and carefully pop it out. Just let it sit out for a few minutes. This is what resets the BIOS, the system's basic startup instructions back to factory settings. And then here's the key part. Before you put that battery back in, hold down the power button for about 20 seconds. This drains all that leftover static charge, sometimes called flea power, that can seriously mess with a clean startup.
Okay, so let's say clearing the scene didn't work. Our patient is still unresponsive. Well, now it's time to bring in the suspects for questioning. We're going to use a classic detective move here, the good old process of elimination. We'll test each major piece of hardware one by one until we find the one that's guilty.
I love this quote because it captures the mindset perfectly. We are not just randomly guessing here. We are systematically investigating. Every single component is a suspect, and we're going to check their alibis one by one. Trust me, this methodical approach is the only way to solve the case reliably.
So, who's in our lineup? Let's meet the usual suspects. First up, we've got the memory, or RAM. It can be really sensitive to power issues. Then there's the graphics card, the GPU. We also have to look at all the cables and anything plugged into the PC. And finally, the big one, the power supply unit, the PSU. This is what gives life to the whole system, and they definitely wear out over time. Chances are, our culprit is right here in this list.
First up for interrogation, the system's memory, the RAM. A single faulty stick of RAM can absolutely stop a computer dead in its tracks. It's often one of the first things to go when there's a power issue. So how do we put it to the test?
The test itself is pretty simple, but you got to be patient. Take out all of the RAM sticks. Now you're going to test them one at a time. Put a single stick into a slot and try to boot. If it doesn't work, try that same stick in a different slot. You're going to repeat this process with every single stick you have. The second that PC boots up with one stick, but it wouldn't boot with another, bam, you've found your culprit.
All right, so let's say all the RAM checks out. It has a solid alibi. Our investigation now moves to the next suspect in our lineup, the graphics card, the GPU. This is another really powerful component that can absolutely be a single point of failure, stopping a boot cold.
And you know what? The test for this one is even easier. You just physically remove the graphics card completely out of its slot. Now, what are we looking for here? We're not necessarily looking for a picture on the screen. We're just looking to see if the system's behavior changes. If those fans suddenly spin up and stay on instead of just flashing for a second, that is a massive clue that the GPU is the problem all along. That change in fan behavior tells you everything you need to know.
Okay, so if we've ruled out the RAM and the GPU, our investigation is really starting to narrow down. Now we're looking at the components that deliver the very lifeblood of the system, power. And that means we got to look at all the cables and then, of course, the power supply unit itself.
But hold on. Before we point the finger directly at the power supply, we have to check its accomplices, the cables. Seriously, a faulty USB drive or a short in one of those fancy custom extension cables can bring the whole system down. So disconnect everything that isn't 100% essential. I'm talking hard drives, case fans, the front panel USB ports, all of it. And if you're using custom cables, ditch them for now and put the originals back in. We need to completely isolate the core system.
Okay, let's recap.
We've interviewed every suspect. We cleared the scene, we tested the RAM, the GPU, and all the cables. And the system is still dead. This is that moment in every detective story, where all the pieces finally start to click into place. We are right on the verge of our aha moment.
So this is it, the final test. When every other suspect has a rock-solid alibi, you bring in a stand-in for the one that's left. We're going to connect a completely different known working power supply. And just look at the difference. With the original PSU, we got that quick flash of the fans and then kaput. But with a good PSU plugged in, the fans spin up and they stay on. The system actually starts to boot. I mean, the evidence here is just undeniable.
And there you have it. After a thorough, step-by-step investigation, we've found our culprit. It wasn't the memory, it wasn't the graphics card. It was the faulty power supply unit all along. It just wasn't delivering stable power to everything else.
But closing the case isn't just about pointing the finger. It's about actually fixing the problem. And hey, maybe making the system even stronger to prevent this from happening again. So let's take a look at the final report.
Now, this is a really important concept to understand, the chain reaction. See, a failing power supply doesn't always just die quietly. It can send out bad or unstable voltage through your whole system, and that can actually damage other, way more expensive parts, like your motherboard or your CPU. That's why finding the bad PSU is so critical. If swapping it out hadn't worked, our very next suspects would have been the motherboard and CPU.
And hey, while you've got the whole case open anyway, it's the absolute perfect time for a few improvements. You can think of it like reinforcing the security system after a break-in. In this particular case, this was a great chance to add a super fast M.2 SSD for storage. That's one of those drives that plugs right into the motherboard. Also doubling the RAM to 16 gigs for a nice performance boost, and of course giving the whole system a good cleaning to help with airflow. So it's not just a repair, it's a full-on upgrade.
So there you go. By following a clear, methodical process, we took a completely dead PC and we solved the mystery. The key is that we didn't just guess, we investigated. And now that you've seen how a PC detective works, you've got the skills to start tackling these kinds of problems yourself. So really, the only question left is, what mystery are you going to solve next?